What is entropy?
A measure of the dispersal of energy. The greater the energy is dispersed, the larger the entropy. As a consequence of the second law of thermodynamics is that the entropy of the system and the environment can never decrease.
What is the coefficient of static friction ms?
Coefficient when there is no relative motion between the two surfaces.
What is the conservation of mass?
Mass is neither created nor destroyed in chemical reactions.
What is reflection?
When light strikes an object, it can either be absorbed, transmitted, or reflected. Opaque objects absorb or reflect light. Transparent and translucent materials transmit light, but can also reflect it. The energy carried by the light must be conserved. The sum of the energy reflected, transmitted, and absorbed must equal the energy that strikes the material. Light energy that is absorbed increases the thermal energy of the material, so the material becomes warmer. Reflection occurs when light bounces off of a surface, such as a mirror or a sheet of paper. A smooth surface, like that of a mirror, reflects light according to the rule that the angle of incidence equals the angle of reflection. Light that strikes the surface at, for example, 30 degrees above the surface is reflected at 30 degrees above the surface. You can test this for yourself with a small flashlight, a mirror, a sheet of paper, and a helper. Hold the piece of paper. Have the helper hold the flashlight. Aim it at the mirror, and move it around until the reflected light ray hits your piece of paper. Change the angle with which the light from the flashlight strikes the mirror and see that you have to move the paper closer to the mirror to have the light hit it.
Why do your ears hurt when you dive to the bottom of a swimming pool?
Just as the weight of the air above us creates atmospheric pressure, the weight of water creates liquid pressure. Close to the surface of a pool there is very little water that can push down and increase water pressure. The further a person dives below the surface, however, the greater the water pressure. The eardrums are especially sensitive to the increased pressure, for they do not have the reinforcement that the diver's skin has. In fact, your eardrums can usually feel pressure when diving just 1.5 to 3 meters, 5 to 10 feet, below the surface of the water. Feet, deep or in the ocean at a depth of 10 meters, 32 feet. Although the ocean contains a lot more water than a lake, it is the depth that determines the weight of water directly over a diver that defines the amount of pressure the diver experiences. Therefore, a diver who is 20 meters below the surface of a lake will experience more pressure. In fact, twice the pressure than the ocean diver experiences at 10 meters. Salt water is denser than fresh water, but the increase in pressure caused by the increased density is small in comparison to that caused by the difference in depth.
What causes the northern lights?
Disturbances on the Sun can send large numbers of charged particles into space. When they reach Earth, they disturb the Van Allen belts, causing the belts to dump particles into Earth's atmosphere. There they interact with the gases in the atmosphere, causing them to emit light. The scientific name for this phenomena is aurora.
What does sustainable energy mean?
The amount of fossil fuels is limited. There have been major advances in discovering oil and extracting more from existing reservoirs, as well as recent advances in obtaining natural gas and oil from shale. But these sources, as well as coal and uranium, are not being replaced. Sustainable energy sources, primarily wind, water, and solar energy, ultimately receive their energy from the sun, and therefore will be available for billions of years. The present use of these sources is minimal. There are many difficulties in increasing their use. Wind power is highly variable. Water energy from traditional dams and reservoirs causes environmental problems. Energy from waves and tides has yet to be developed widely. Solar energy can be directly converted to electricity using photovoltaic cells. But these cells, at least at present, are inefficient and costly. Large solar farms exist, at which solar energy heats a fluid so it can boil water to use with steam turbines driving electrical generators. An additional problem in increasing the use of many of these sources is that they require the use of very rare materials, which are both costly and not easily obtained. Nevertheless, recent analyses suggest that a combination of nuclear, wind, water, and solar energy could replace most of the use of coal and oil for electric energy production.
How much extra energy is needed to heat the pan?
The answer is found by multiplying the specific heat capacity of aluminium, 897 J/kg degree C, by the mass, 0.3 kilograms, and by the temperature change, 80 degrees Celsius, to obtain 144,000 J or 144 kJ. So the total energy needed to heat both the water and the pan is 814 kJ. Note how much more energy is needed to heat the water than the pen. Look through the list of specific heat capacities on page 125 to find other metals from which you could make a pen that would need less energy to heat it. The high specific heat capacity of water makes it a good material to use, for example, in cooling an automobile engine by circulating the water through the engine where the water is heated, and then through the radiator where flowing air can cool the water.
What is the electromagnetic spectrum?
The electromagnetic spectrum is the wide range of electromagnetic M waves from low to high frequency. The spectrum ranges from low-frequency radio waves all the way to gamma rays, which have a very high frequency. In the middle of the spectrum is a small region containing the frequencies of light.
What is a supersymmetry?
Proposed theory to solve difficulties with the Standard Model in which each boson has a supersymmetric fermion partner particle or sparticle, and each fermion has a supersymmetric boson sparticle.
Why is measurement so important for physics?
While Aristotle, 384 to 322 b. CE, emphasized observation rather than measurement or experimentation. Astronomy required measurements of the locations of stars and wanderers, now known to be planets. The study of light was another early field that began to emphasize experimentation and mathematics.
What is a kilogram, kg?
The mass of a platinum-iridium cylinder that is permanently kept near Paris.
Why does the gravitational field depend on the distance from its center?
This is not an easy question to answer. Newton recognized the problem and had to develop a new mathematics, the integral calculus, to solve it. His argument, simplified, can be illustrated with a wooden button. Hold it at arm's length in front of a window so you can see a tree. Note how much area the button covers on the tree. According to Newton, assuming that the button and tree were made of the same material, the force of attraction of the button on you is exactly the same as that of the part of the tree the button covers. The reason is that the effect of the button being closer is balanced by the much larger mass of the International Space Station orbits at about 320 kilometers above Earth's surface.
What is the difference between a motor and a generator?
In each device, a magnet and a coil of wire are employed to change one form of energy into another form. A motor consists of multiple loops of wire placed in a magnetic field. Either the loops or the magnet can rotate. The current through the wires in the field causes a force that results in rotation and thus mechanical energy. Motors in a home are used in fans, hair dryers, and food processors. There are over 100 motors in a modern automobile. The starter motor is the largest and most powerful. A generator does the opposite of a motor, it changes mechanical to electrical energy, but still consists of multiple loops of wire in a magnetic field. Either the loops or the magnet can rotate. In an automobile, a form of a generator, called an alternator, uses some of energy from the engine to charge the battery. Backup generators use the energy from a gasoline engine to produce enough electrical energy to keep some of the lights and appliances running in a house when the electrical power fails. Electric utilities use huge generators to provide power for a city or larger area. The generators get their energy from steam turbines. The heat required to turn water into steam can come from coal, oil, natural gas, or nuclear burners. Wind power uses generators turned by the propeller blades.
What is precision?
How well the results can be reproduced.
How does the spectrum of a sound relate to its waveform?
Jean-Baptiste Fourier, 1768–1830, a French mathematician and physicist, made discoveries in a number of fields, including the greenhouse effect. He developed mathematical tools known as Fourier series and transforms that are used in a wide variety of applications. The Fourier Theorem states that any repetitive waveform can be constructed from a series of waves of specific frequencies, of fundamental and higher harmonics. The reverse is also true if you add together waves of frequencies f, 2f, 3f, etc., specifying their amplitudes, you can construct a complex waveform. Using Fourier analysis, then you can record the waveform of a musical instrument and determine the amplitudes of the harmonics of which it is made, that is, its spectrum. Today Fourier analysis is very easy to do. Most computers either have built-in microphones or can use an external microphone. Free software can be downloaded from the web that will display the spectrum.
What is a half-life? When will a particular radioactive nucleus decay?
It's impossible to know. All that can be known is the average time between formation and decay. and we know that the number of decays will be proportional to the number of nuclei present. Now, suppose we start with a large number of nuclei. In a given time interval, say 1 second, a certain number will decay. At the end of that second, the number of nuclei that haven't decayed will be smaller. So in the next second there will be fewer decays. At some time there will be only half as many decays in a second as there were originally. That time is called the half-life. One half-life later there will be only V4 as many decays as at the beginning. After another half-life there will be half again as many, or 1/8 the number of initial decays.
What is a law?
Summary of many observations that describes phenomena.
How are radio telescope arrays used?
A group of 27 radio telescopes, each 25 meters, 82 feet, in diameter, spaced as much as 13 miles apart from each other in Socorro, New Mexico, is known as the Very Large Array, VLA. The signals from this group of radio telescopes are combined by a computer. Constructive and destructive interference between the signals allows the array to make very accurate measurements of the location and size of objects. Larger still are very long baseline interferometry radio telescopes. These radio telescopes are located around the world. Cables can't be used to combine the signals. So each telescope needs a very precise clock to determine the arrival time of the signals. Hydrogen masers, whose frequency is stable 1 part in a million billion, are used. Again, although the signal strength is small, the wide spacing increases the effectiveness of using interference to measure very fine details of the shape, size, and location of stars and galaxies.
What is entropy?
The German physicist Rudolf Clausius, 1822 to 1888, was concerned about Carnot's use of the term waste heat. He developed another version of the second law that involves the concept of entropy. Entropy can be defined as the dispersal of energy. The greater the dispersal or spreading, the larger the entropy. For example, when salt and pepper are in separate piles, the two substances are in distinct locations. If you mix them together, they are no longer in separate regions of pure salt and pure pepper, but dispersed throughout the combined pile. Further, it is not possible for the salt and pepper grains to separate themselves. Thus the mixing of salt and pepper increases the entropy of the system. If the salt and pepper could be shaken in such a way that they would separate, then entropy would be decreased. But such an event has never been observed. Suppose you place ice in water. Ice and water are separate. The water has higher thermal energy, the ice lower, and so the system has low entropy. When the ice melts, the two can no longer be separated. The thermal energy is dispersed throughout the system, so the entropy has increased. But wait, you might say, the ice water, the system, has cooled the air around it. The environment, decreasing its entropy because hot gas has greater entropy than cold gas. Calculations, however, show that the increase in the ice/water mixture is greater than the decrease in the air. So a statement of the second law is that the entropy of the system and the environment can never decrease. The increase in entropy suggests a direction of time, sometimes called the arrow of time. The forward direction of time is the one in which entropy increases or remains the same. Clausius had given Carnot's work a firmer foundation. Later work by Ludwig Boltzmann, Josiah Willard Gibbs, and James Clerk Maxwell developed the statistical basis for entropy.
What are paramagnet materials?
Caused by unpaired electrons in atoms. Material is attracted by magnetic fields.
Does a gas or a liquid exert a friction-like force?
If you stick your hand out of the window of a moving car, you can explore the properties of air drag. The faster you go, the stronger the force. If your palm is facing up or down, the drag is much smaller than when your palm faces forward or backward, showing that the shape of the object matters. A smaller hand experiences less drag than a larger one. So, drag depends on velocity, area, shape, and the density of the air. These properties are different from other contact friction forces. But the force is still exerted in the direction opposite motion, so it slows down the object. Liquids exert similar, but stronger, drag forces.
How then could atoms last billions of years?
Rutherford offered no answer. In addition, as the electron spiraled into the nucleus, it would create a smear of all colors of light. But hydrogen was known to produce only specific colors, called an emission line spectrum.
What is the island of stability?
All the isotopes of elements beyond lead are radioactive. Some have lifetimes of tens of millions of years, while others are fractions of a second. Nuclear physicists and chemists know that isotopes that have magic numbers of neutrons or protons are more stable than others. They have proposed that very heavy isotopes with a neutron number around 180 and a proton number around 110 should be more stable than those with fewer or greater neutrons and protons. A glance at the table of elements beyond uranium shows that elements around 110 have longer lifetimes than others. But researchers have not yet been able to create isotopes with enough neutrons to reach this island.
How is the strength of an electrical force measured?
British philosopher, theologian, and scientist Joseph Priestley, 1733–1804, suggested that the force caused by static electricity might depend on distance the same way gravity does. Using Priestley's idea, the French physicist Charles Coulomb, 1736–1806, made quantitative measurements of the force of attraction and repulsion between charged objects using an apparatus shown in the accompanying illustration. He found that the force depended on the charge of the two objects and the distance between them. The relationship he found is called Coulomb's law, and the unit of measurement of charge as the coulomb, c.
What is active noise cancellation, ANC?
Device that creates a waveform that is the opposite of the noise so that the noise is cancelled.
What is reflection?
Light or other wave bounces off a surface or interface between two media.
What is work?
Energy transfer by mechanical means.
Why does sound diminish as you move farther from the source?
Sound waves do not travel in a narrow path, but spread out into the surrounding medium as spherical waves. As long as the energy in the sound doesn't change, the power per unit area decreases as the area increases. In some cases, there is some transfer of the sound's energy into thermal energy of the medium. Thus, there can be some loss of sound energy with distance, but this loss is usually small.
Who introduced the modern chemical symbols?
Swedish chemist Jöns Jacob Berzelius, 1779–1848, introduced the modern chemical notation using one or two letters to represent an element in 1813. Rather than today's notation for water, H2O, Berzelius wrote H2O. Berzelius did much more. He published the first accurate list of the weights of atoms.
What is optics?
Area of study within physics that deals with the properties of and applications of light.
What is a fluid?
Solids retain their shape because strong forces hold the atoms in their places. In a liquid, the forces keep the atoms close together, but they are free to move. In a gas, the atoms are about 10 times further apart than in either solids or liquids, and forces between them are very weak. As a result of weaker forces, a liquid or gas can flow freely and assume the shape of their container. They are called fluids. There are two main areas of fluid study. The field that studies fluids in a state of rest is called static fluids. And the field that analyzes the movement of fluids is called fluid dynamics. We will first explore static fluids.
Why do you sometimes get a shock when touching a doorknob?
This annoyance happens usually on dry days after walking on carpeted floors. The friction between the carpet and your shoes or socks causes charges to be moved between your body and the carpet. Usually your body becomes negatively charged. When your hand approaches a doorknob, the negative charges in your hand are attracted to the positive charges in the doorknob, created by polarization, causing an electrical spark when the two charges meet. Circuit boards are sensitive to electrostatic buildup and can be damaged if such a charge accumulates on sections of the circuit.
How do you convert from one scale to another?
Use the conversion chart below to convert between Celsius, Fahrenheit, and Kelvin. From to formula Celsius Kelvin degree C equals K plus 273.
What is the nuclear model?
Extremely small positively charged particle, the nucleus, surrounded by electrons.
What are maglev trains?
Maglev, or magnetically levitated trains, are different from conventional trains in that they use electromagnetic forces to lift the cars off the track and propel them along thin magnetic tracks. Some demonstration trains have reached speeds of 500 km per hour, 300 miles per hour. Although the United States has no maglev train, nor an active research program in this technology, Germany and Japan have conducted a great deal of research in the field.
What is a wave?
A wave is a traveling disturbance that moves energy from one location to another without transferring matter. Oscillations in a medium or material create mechanical waves that propagate away from the location of the oscillation. For example, a pebble dropped into a pool of water creates vertical oscillations in the water, while the wave propagates outward horizontally along the surface of the water.
What is the diffraction of light?
Reflection and refraction use the ray model of light. But, when light goes through a very small opening, the ray model is no longer sufficient. The wave properties of light become important. Suppose you pass light through a round aperture whose diameter you can change. Let the light fall on a screen. As you first begin reducing the size of the hole, you'll find the size of the bright spot shrinking. But, when the hole becomes very small, a strange thing happens. The spot no longer shrinks, but its outer edge becomes fuzzy. Light begins to bend around the edge of the hole. Diffraction also occurs when light is sent through narrow slits or if there are small objects that cast shadows in a broader beam of light. Diffraction occurs with all types of waves. You can often see it in water waves, and it is one reason that sound waves spread when they come through a door or window.
What is the difference between transparent and translucent?
Transparent media such as air, water, glass, and clear plastic allow light to pass through the material. Rays of light are either not bent or closely spaced rays are bent together. Translucent materials, on the other hand, allow light to pass through, but bend closely spaced rays into different directions. For example, frosted glass and thin paper are translucent because they let light through, but are not transparent because you cannot see clearly through them.
What is a wave?
A traveling disturbance that moves energy from one location to another without transferring matter.
Does the momentum of your hand change?
Of course, your hand is just a part of your body. And if you are standing firmly on the ground, your body is unlikely to move. Let's pick a simpler situation. Suppose you are sitting in a desk chair with wheels on a smooth floor and you catch a heavy ball thrown by someone. In this case, you and the chair will roll backward. In other words, the momentum of you and the chair will increase as the momentum of the ball decreases.
Who predicted electromagnetic waves?
In 1861, James Clerk Maxwell, 1831 to 1879. Demonstrated the mathematical relationship between oscillating electric and magnetic fields. In his treatise on electricity and magnetism, written in 1873, Maxwell described the nature of electric and magnetic fields using four differential equations, known to physicists today as Maxwell's equations. Putting the four equations together predicted the existence of the electromagnetic wave. Maxwell was a professor at Cambridge University in England from 1871 until his death in 1879. He published other works on thermodynamics and the motion of matter as well. He also developed the kinetic theory of gases, and performed research in the field of color vision. Although Maxwell is not widely known to the lay audience, he is revered in the scientific community and rates in the pantheon of physics greats with Newton and Einstein.
What is a magnetic declination?
Angular difference between north as shown by a compass and the direction to the geographic North Pole, Earth's axis of rotation.
How can these two quantities be equal?
The answer can be found by looking at Newton's second law again. In the form Fnet equals ma, you can see that the units of force, newtons, must be equal to the units in which m times are measured. The mass, m, is measured in kilograms and the acceleration in meters per second squared. Therefore a newton must be a kilogram times a meter per second squared. Thus a newton per kilogram, n/kg, is a meter per second squared, m/s2.
What is the boiling point?
Temperature at which pressure of the water vapor equals the atmospheric pressure.
What is a dark matter?
Matter in universe that does not interact with electromagnetic radiation but does interact with gravity. Comprises 23% of mass of universe. Its composition is unknown.
How does the human eye see?
The eye is really an extension of the brain. It consists of a lens to focus the image, an iris to regulate the amount of light entering the eye, and a screen called the retina. The cells of the retina do some preliminary processing of the information. They receive then send signals along the optic nerve to the brain. The cornea is a transparent membrane on the outer surface of the eye. Between the cornea and lens is a fluid. Light refracts when going through the convex surface of the cornea into the fluid. In fact, most of the focusing of light in the eye occurs at the cornea. Light passes through the iris that opens and closes in response to the amount of light entering the eye. The iris can only change the amount of light to a going through it by a factor of 20. While our eye can respond to differences in light level of 10 trillion. The major task of the iris then can't be to control light intensity. In addition, when the opening in the iris shrinks, the eye can keep objects in focus from a wider range of distances. After passing through the iris, the light goes through the lens. The lens consists of layers of transparent fibers covered by a clear membrane. In order to focus in on objects that we want to see, our eye changes the shape, and thus the focal length of the lens and cornea by contracting or relaxing the ciliary muscle around the eye. Light then passes through a liquid called the vitreous humor. That fills the major volume of the eye and falls on the retina. The cornea and lens have created an inverted image on the surface of the retina. The retina is composed of a layer of light-sensitive cells, a matrix of nerve cells, and a dark backing. There are two kinds of light-sensitive cells, cones and rods. The 7 million cones are sensitive to high light levels and are concentrated around the fovea. The part of the retina directly behind the lens. Surrounding it are some 120 million rods that are sensitive to low light levels. The entire retina covers about 5 square centimeters. There aren't 127 million nerves in the optic nerve that goes to the brain. So a system of nerves in the retina do some preliminary processing of the electrical signals produced by the rods and cones before sending the results to the brain.
What are some of the largest reflecting telescopes?
The larger a reflecting telescope, the more light it can gather. The following is a list of some of the largest reflecting telescopes in the world.
How can you describe the path of a thrown ball?
You know what happens when a ball is dropped. It accelerates downward, gaining speed at a rate of 9.8 m/s each second.
How did fiber optics originate?
The idea that light could travel through glass strands originated as far back as the 1840s. When physicists Daniel Collodon and Jacques Bobinet, 1794 to 1872, demonstrated that light could travel through bending water jets in fountains. The first person to display an image through a bundle of optical fibers was a medical student in Germany by the name of Heinrich Lamm, who, in 1930, used a bundle of fibers to project the image of a light bulb. In his research, Lamb ultimately used optical fibers to observe and probe areas of the human body without making large incisions. From that point on, serious research in optical fibers ensued, expanding later with the development of the laser. Fiber optics are glass fibers that transmit laser light that can contain digital information more quickly and efficiently than metal cables.
How much does a moving clock slow down?
A clock on a jet plane, V equals 550 miles per hour, would lose 0.9 milliseconds per year. While one in the space shuttle, V equals 17,500 miles per hour, would lose 0.9 s/year. In 1971 atomic clocks were placed on planes, one of which flew around the world eastbound, the other westbound. The changes in time were measured and agreed with relativity theory. Clocks on GPS satellites must be adjusted for the loss of time. More conclusive tests have been done with very fast-moving, 0.995 c, muons. Muons, when at rest, decay in 2.2 ps, microseconds. The number of muons, produced high in Earth's atmosphere by cosmic rays, were measured at the peak and base of a high mountain. The ratio of numbers at the two heights showed that the muons lived 22 ps, which agreed with their measured speed of 0.995 c. From the viewpoint of the muons, they decayed in 2.2 ps. But the height of the mountain was 10 times shorter than that measured by observers on Earth. Thus the predictions of slower clocks and shorter distances have been tested and agree with Einstein's predictions.
What is farsightedness?
Also called hyperopia. Allows only objects far from the eye to be focused on retina. Images from close objects are behind the retina, so they are blurry.
What is a white light?
The combination of all the colors in the visible spectrum.
What happens if you look at a mirror while lying down?
Now left and right are not reversed. Your chin is on the same side of both you and your image. But if your right eye was higher than your left, then in the image the left eye will be higher.
What is a light year?
A year is a unit of time, but a light year is a unit of distance. Specifically, it is the distance that light travels in 1 year. Since light travels at 299,792 km per second and a year consists of 31.557 x 106 s. A light year is 9.4605 x 1012 km or about 6 trillion miles. The light year is used to express distances to stars and galaxies.
What is a laser tweezer?
When a laser is sent through a microscope, it creates a tiny spot of very intense light in the material on the slide. A tiny plastic sphere will interact with the light in such a way that it is pulled into the center of the light. The light can be moved around the slide, dragging the sphere with it. That is the essence of a laser tweezer. The sphere can be chemically attached to the end of a long molecule, such as DNA. When the other end of the DNA is similarly fastened to the surface of the slide, the sphere can be used to stretch the DNA, straightening it out, and measuring properties such as the force needed to stretch it. Proteins, enzymes, and other polymers can be used in place of the DNA, and the forces they exert similarly measured. In addition, the tweezers can be used to sort cells, moving them to specific locations on the slide. We'll explore other mysterious consequences of quantum mechanics in the last chapter. Unanswered questions.
What was done in Los Alamos?
In September 1942, General Groves and Robert Oppenheimer chose Los Alamos, New Mexico, as the site for the top-secret laboratory at which weapons would be developed. 35 miles northwest of Santa Fe. It was almost totally isolated, and the site was occupied only by a school. During World War II, hastily erected housing held Nobel Prize-winning scientists. Younger scientists and engineers recruited into the project, wives and children, and soldiers. After determining the critical mass, the minimal amount of enriched uranium needed to create a bomb, they designed and built the uranium-based weapon called Little Boy. The uranium was divided into two halves and placed in a cannon-like container. An explosive charge drove the two masses together, forming a large enough mass of uranium to sustain a rapid chain reaction and explode. This weapon was never tested. It contained 64 kilograms, 141 pounds, of uranium, about 2.5 times the critical mass. Less than 1 kilograms, 2 pounds, of the uranium fissionate. Only 0.6 grams, 0.001 pounds, was converted into energy. But the result was the equivalent of 15,000 tons of TNT. Little Boy was dropped on Hiroshima, Japan. On August 6, 1945. Over 100,000 people were killed in the blast, resulting fires and effects of radiation. The second task of Los Alamos was to design and build a weapon using plutonium. Originally they had expected to use the cannon-type method used with the uranium bomb. But when the plutonium was produced by the Hanford reactors, it was found to contain 240 Pu. And another design had to be developed. They arranged a subcritical plutonium mass in the shape of a sphere and used specially designed explosive charges to simultaneously compress the plutonium, increasing its density above the critical point. Scientists were uncertain that the design would work, so they decided to test the device first.
What is the Mach number?
Ratio of a velocity to the speed of sound.
What is a voltaic pile?
Or battery in which chemical energy is converted into increased energy of electric charges.
What is ultrasound?
Ultrasound is a method of looking inside a person's body to examine tissue-based and liquid-based organs and systems without physically entering the body. Ultrasound systems direct high-frequency sound, usually between 5 and 7 MHz, into particular regions of the body, and measure the time it takes for the sound wave to reflect back to the machine. By analyzing the pattern of reflections received, a computer can create a visual representation of the interior of the body. Dolphins can detect frequencies of between 110 and 130,000 Hz. Their hearing is over 6 times more sensitive than that of a human being. Ultrasound is sometimes used instead of X-rays because it does not use ionizing radiation and thus is safer for the person being examined. Obstetricians use ultrasound to examine the progress and/or problems that a fetus might be experiencing. Ultrasound is also used to observe different fluid-like organs and systems in the body such as the nervous, circulatory, urinary, and reproductive systems. Ultrasound can also be used to pulverize kidney stones. In this application, very intense, tightly focused beams of high-frequency sound are directed at the stone. The stones are shattered and the small pieces can be passed through the urinary tract with little or no pain.
What is the difference between the umbra and penumbra of a shadow?
A shadow produced by a large light source has two distinct regions. The umbra is the area of the shadow where all the light from the source has been blocked, preventing any light from falling on the surface. The penumbra, or partial shadow, is a section where light from only part of the source is blocked. resulting in an area where the light is dimmed, but not totally absent. During an eclipse, the region of total darkness is the umbra. No direct sunlight can reach this area, resulting in a total eclipse. As Earth rotates, the Moon's shadow races across Earth, producing the path of totality. Regions on either side of the path of totality experience the penumbra shadow and see the Sun only partially covered by the Moon.
What are transformers?
An impedance matching device is called a transformer. Instead of an abrupt change between the two media, a transformer provides a smoother, gradual transition from the old to the new medium. Depending upon the wave and the medium, different transformers, such as quarter wavelength and tapered transformers, can be used to help minimize reflection. An example of a tapered transformer can be found in soundproof rooms or sound studios. Any sound that is produced is supposed to be absorbed by the impedance matching material on the walls. Special foam, tapered in a V-like shape, is used as a transformer to gradually absorb all the sound into the walls. The gradual changeover from the air medium to the wall medium prevents sound from reflecting back into the air. An example of a quarter wavelength transformer can be found on many camera lenses and eyeglasses. The quarter wavelength thick coating on a lens is used to reduce reflections off the lens surface, allowing more light into the lens. Electrical transformers are also used to match impedances by changing the varying voltages and currents in an electronic circuit. Modern electronic circuits make very minimal use of transformers because of their weight and size.
Why are many water towers placed on high towers?
The height of the water determines the pressure. Since a holding tank is up high, it places a lot of pressure on the water in the rest of the water network. The tank should be as large across as possible so that for the same amount of water the vertical dimension of the tank can be as small as practicable. This design limits the variation in pressure as the tank empties or is filled.
How are conservation of momentum and conservation of energy used in everyday life?
These two laws are most often used when two objects collide. Momentum is conserved if there are no external forces, and it changes very little if the forces during the collision are much greater than the external forces. For example, if two cars collide, the two cars are the system. The forces between them are much larger than the forces on the wheels that come from outside the system, so momentum is conserved.
Why is a wedge like an inclined plane?
A knife is one example of a wedge. Look carefully at the sharp edge of a kitchen knife. It looks like two inclined planes put back to back. As the knife blade moves down through food, the wedge pushes the pieces apart. A hatchet or axe is another example of a wedge. Wedges are also used to split wood. In this case, the flat end of an axe is often used to drive the wedge into the end of a log, which is then forced apart. Wedges are inefficient machines because there is usually a large amount of friction between the wedge and the material, which leads to increased temperature of both the material and wedge, and thus heat transfer.
What are beta particles?
Electrons emitted at high energy by some radioactive nuclei.
How do one-way mirrors, the ones used in interrogation rooms, work?
A one-way mirror seems to be a mirror when seen from one side, but as a window when seen from the opposite side. Thus the window is disguised as a mirror to allow secret surveillance. Physically, there is no such thing as a one-way mirror. That is, the amount of light reflected from one side is the same as that reflected from the other. The light transmitted in one direction is equal that transmitted in the opposite direction.
Does velocity affect distance and time?
Einstein's special theory of relativity shows that both distance and time change with velocity. Einstein reached this conclusion by noting that one must define methods of measuring both distance and time. The result is that as objects move near the speed of light, their length in the direction of motion shrinks, and their internal clocks that measure time run slower. The amount of change is described by a factor called y, gamma, which is always larger than 1. Thus the time given by a moving clock is yt, where t is the time shown by a fixed clock. And length is given by Li, where L is the length of the fixed object.
What is a coordinate system?
A set of axes used to locate an object, usually defined at the reference location. Cartesian coordinates are three directions at right angles to each other. Usually the x, y, and z directions.
Aren't there three laws of motion? What is Newton's third law?
Forces are interactions between objects. You need more than one object to have a force. Therefore, if two objects interact, each exerts a force on the other. If you push on a friend's hand, his or her hand pushes back on you. If you stand on a floor, you exert a force on the floor and the floor exerts a force on you. Newton's third law of motion states that these two forces are equal in magnitude but opposite in direction. If you exert an 800 Newton force downward on the floor, the floor exerts an 800 Newton force upward on you. Note that Newton's second and third laws are different. The third law describes forces on two different objects. Those forces can then be used with the second law to find out how the motions of the objects are changed.
How does a hydraulic lift work?
Pascal's principle states that pressure in a liquid is independent of direction. Pressure is force divided by area, so force exerted by a liquid is equal to the pressure times the area. A hydraulic lift has a small piston in a cylinder. If you exert a force on the piston, it will create a pressure in the fluid. The lift also has a second, large area cylinder and piston. The fluid creates a pressure in the cylinder that exerts a much larger force on the piston because of its larger area. Therefore, the lift has a mechanical advantage. Of course, energy is still conserved, so the small piston must move much farther than the large piston. An automobile lift, used in many automotive repair shops, allows the operator to use very little force to lift an automobile off the ground. By pushing liquid from a small diameter cylinder and piston through a thin tube that expands into a larger diameter cylinder and piston, which is located beneath the vehicle to be lifted. Since the liquid cannot be compressed like air, the liquid from the small cylinder is pushed into the large cylinder, forcing the large piston to move upward.
How is light detected?
Light carries energy, so a light detector must convert light energy to another form of energy. In most cases, light is converted into electrical energy. In the eye, which will be discussed more thoroughly later in this chapter, light strikes a molecule called an opsin. The absorption of light changes the shape of the molecule, which results in an electrical signal sent on the optic nerve. In detectors used in digital cameras, when light is absorbed in a semiconductor, one or more electrons are released. The charge they carry produces a voltage that is then converted into a digital signal. In photographic film, molecules consisting of silver and chlorine, bromine, or iodine are used. When light strikes these molecules, it transfers its energy to electrons. The molecules are broken apart and a tiny crystal of metallic silver remains.
What is a spectrum and what are continuous and line spectra?
Newton showed that when white light is passed through a prism it is split into a spectrum of all colors from violet through red. There were no gaps between the colors, so the spectrum is called continuous. The emission line of sodium has only 2 yellow lines. Hydrogen has 4 lines. The spectrum of iron, on the other hand, has an extremely large number of lines. An absorption line spectrum occurs when the low-density gas absorbs distinct colors, leaving dark gaps in the otherwise continuous spectrum. For example, the spectrum that the German physicist Joseph von Fraunhofer (1787–1826) took of the spectrum of the Sun in 1814 showed 574 dark lines. In 1859 they were explained as being absorption lines from the cooler gases in the Sun's atmosphere. Fraunhofer made the best optical glass of any glassmaker of his era. He made great improvements to the achromatic lens, which refracts light of all colors the same amount. Like most glassmakers of his era, he died young. Most likely from the poisonous effects of the materials used to make the glass.
What did Benjamin Franklin's famous kite experiment prove?
Benjamin Franklin is probably most famous for flying kites in thunderstorms. In the mid-I-700s there were 3 different phenomenon that had similar effects. You could draw sparks with frictional or static electricity. Lightning appeared to be a giant spark, and electric eels could cause shocks like static electricity. But no one knew if these 3 had the same or different causes. Franklin touched a Leyden jar to a key tied to the string of his kite. When sparks jumped from the cloud to the kite, the charges went down the string and charged the Leyden jar. Thus Franklin showed that lightning and frictional electricity were the same. Benjamin Franklin did not discover electricity, but he did show that lightning and frictional electricity were the same thing with his famous kite experiment involving a key and a Leyden jar.
What is a positron?
Antimatter form of electron with same mass but positive charge. Emitted in decay of radioactive nucleus or as result of collision of high-energy gamma ray with the nucleus.